Okay, today we're talking about colors. Yeah. Oh, you're here, so we should put a U in there. Go Europe, right? Ha ha ha. Or Canada. Okay, so there's two kinds of colors, and we're first going to talk about primary colors. You know what primary means? It means first colors. First. Hey, so these are your primary colors. You've got red for the blood of angry men, but not black. I'm sorry. But you also have green. Does that bother you a little bit? Did they always teach you yellow? I'm sorry, they lied. So there's red, then there's green, and there's blue. Those are your three primary colors. And that's all I'll be able to hear. So, why are these your primary colors? These are primary colors for one reason. These are primary because they each activate, one cone in your eye. Alright, so when you're looking at this circle right here, which I can't draw on because it's the same as my pen and I can't change it because they changed the settings in this program. The reason why you know it's red is because there's one cone in your eye that's saying, hey, hey, there's a color, there's a color. And then the other two cones are like, no, I don't see it. All right. And then when you look over here, you're going to, the other cone's like, oh, I see it now. But then the first cone is like, I lost it. And then the third one's the same thing. So that's why these are your primary colors. Each one of these activates a single cone in your eyes. All right, let's talk about secondary colors. Oh, you'll never guess what these ones do, huh? So secondary colors each activate two cones because that's why they're called secondary. All right, so let's talk about the choices here. You have your friend yellow. Now, I know as a gentleman I want to say purple, but the technical name for this is magenta. Okay? I know, it's like a pinkish purple, but whatever. I'm going to probably call it purple sometime soon anyways. Now, this guy is the light blue. It has a fancy name though, and it is cyan. We're calling it these colors because these are the colors for... These are the names of these particular colors that have these properties. Okay, now each one of these activates two cones. So let's say you looked at yellow. Okay, what's happening? In your eye, you've got three cones. You've got a red one, a green one, and a blue one. For yellow, well, I'll tell you what, let's make this have a little more room here. So you've got your red, green, and blue cones, right? For yellow, what's going to happen? Whoa, there's a straight line. Which cones are going to be turned on? Well, your red cone is going to be turned on, and your green cone is going to be turned on. Your blue cone is like, where? I don't see it. Yes. So because both of these red and greens are are triggering at the same time, your brain knows it's the color in between, which is yellow, right? Roy G. Now let's talk about cyan, or blue, but cyan. All right, what's talking about cyan? Cyan, well, your blue is going to wake up in this one, but it is going to be paired up with green. So this is when blue and green get triggered at the same time. Blue and green make cyan. Okie dokie, artichoke, and, well, I think you can figure it out. For magenta, you're going to have red and blue, right? Red and blue. That's easy to read. Make magenta. So this is when both those cones are activated at the same time in your vision. All right? So this is how you can see more colors. If we take this and expand it, we're going to be adding colors together now, okay? Now, you may have noticed that you can see colors on the computer screen. Like, do you see the colors right here on the computer screen? What color pixels are lit up there? If you said yellow, you're wrong. There is no yellow pixel in that area. I promise you. You can look very, very closely if you want, but it's not going to matter. What's really happening there is there's a pixel here, and a pixel here, and a pixel here, more or less. Now, this one has a red light bulb in it, this one has a green light bulb, and this one has a blue light bulb. Now, in this area right here, if we zoomed in very, very, very closely, what would happen is the green one would turn on. Isn't it bright? And the red one would turn on. Right? But the blue one would not turn on. Okay? So this is adding colors together. Okay, so when you're adding colors together, you're usually mixing primary colors to get a secondary color at this point. Yes, there are tertiary colors. Okay, we're not going to really deal with those. I mean, it's just a secondary plus another primary, all right? It's just different weightings. But one thing here, so we know that this one, and here's a little chart here in case you didn't notice it yet. But, you know, your green plus your blue is going to be your cyan, your red and your blue makes your magenta. Now, in the middle here, you have white. White is for all three cones together. All right, so all three cones are lit up at the same time, and that's going to be your white color. Right, that's it, man. So you can make different shades if you wanted to make. Let's say we took our yellow, right? So this is yellow, but you wanted a lighter yellow, a pale yellow, a pastel yellow. Okay, what are you going to do to get a lighter color yellow? Well, what you're going to do is you're going to take this same setup here. So red is going to be lit up at 100%. Green is going to be lit up at 100%. But blue is only going to be lit up at about 50%. All right? So this is what happens. All three lights are on, but they're on to different proportions. Okay? Now we're adding here. So this will make a yellow, but it'll make a very light colored yellow. All right? And you can pick whatever numbers you want, and there's, you know, that's what your little color palette does, basically, is it lines them all up, and then or you can just type in which values you want. Alrighty, so let's talk about another friend, subtraction. Subtraction works in a similar kind of way, but instead of thinking of lights, it would be easier to think of paints. Okay, so this is how paint works as opposed to light. Now, I don't have any painting to give you right now, but here's how paint works. Let's pretend I've got a red paint. Okay, so this is red. If I used red paint, how would it be red? Well, the light that's coming in, let's assume you're outside, so you've got white light, remember? So white light is going to be coming in to here. It's going to hit all three colors. Red, G, and B are all going to hit that red painted block, right? But you see it as red. You see it as not at white. So only the red color is going to reflect. The other two colors are just going to stay put, or going to be absorbed as heat. You know, they're not going to bounce off of there. They're not going to reflect. They're going to be absorbed. Okay, that's how subtraction works. So when you have a material like paint, like this subtracts green and blue light away. Okay, now if you've got a secondary color, what that means is, so let's say instead of painting it red, I painted it magenta, all right? Now, if I have my white light here, all three colors are going to go in there, so it's going to be red, green, and blue. Now, since you see it as magenta, what do you see? Do you know? What are the colors that you see there? You're going to see red and blue. So this means that magenta is going to absorb the green only. So the magenta will get hot in the sun, a little bit cooler than the red, actually. But whatever. Okay, does that make sense? I hope so. You'll have to talk louder if you have a question. Now that we have this, we're ready to mix colors together. Okay, so let's say that I had a paint bucket, right? So basically it's bricks that I can mix, okay? So I put in a red paint. I'm going to just combine the two that we did. And I put in a magenta paint, okay? And I stirred it real good. So it's all mixed together now. What color would the paint be? Let's say they're all equal proportions and all that stuff, okay? The color would still be basically magenta. Now it would be a more reddish magenta because, you know, ratios kind of stuff, but your light's coming in, your RGB. Now your red can still bounce off. Oh, I'm sorry. I said the wrong thing. It would not be magenta, it'd be a red. It'd be a red color because the red is going to block out the blue. So the blue from the magenta isn't going to reflect anymore because it's blended with the red color, which does not allow that. Okay? So it is going to look red even though you added magenta to it. It's going to have the same type of reddish coloring. All right? Now, this is how your computer printer works. Your computer printer can print anything because it uses this. If you need to print something that is red, your computer has only 3 colors in its ink cartridge. It has cyan, yellow, and magenta. So if it wants to print something red, it throws down both magenta and yellow at the same spot. The magenta blocks out the green. The yellow, remember, if it's yellow, it's made out of red and green. So that means this is going to block out the blue. Now, since green and blue are both blocked out, that's how you get the red color here. So red is made by mixing yellow paint and magenta paint. And the same thing for blue and yellow makes green. This is probably closer to the color wheel that you remember from school, because when they taught you this, they taught you subtraction because you were using paint. All right, and then finally, black. If you see the red door and you want it painted black, you really just need to mix the red paint with the other 2 colors, cyan and yellow, because each one of them blocks out one of them. It's like you could think of yellow as not blue, and you could think of this as not red. Right? So not red, not blue, and not green is going to be black. Right? Now, this makes sense because black is when you have no cones that are activating. All right? If it's very, very dark, or you close your eyes, don't get scared. It's going to be okay. If you close your eyes, you will see no light coming in. Well, very little light going in. All right? Now, that's why it's black, because there's no activation. There's no light. If you look at something in the room that's black, like a pen or clothes or whatever, that's because there's no light bouncing off of those and into your eyes. All right, and that's it. Now, just like before, we talked about making some different shades. If you wanted to make some yellow, right, and you wanted a darker yellow, like a mustard school shirt color, you know, like the popular school color shirt that everyone's wearing all the time. So what you would do is you would have red and green, but you'd only put them on at 75% instead of both at 100%. That'll give you a cooler yellow, if you want to think of it as cooler. All right? Like a more mustard color. Anyways, so that is color subtraction. This is how you can make colors. If you want to use paint, you're going to be using subtraction. If you want to use light, you're going to be doing addition. Okay. Hey, and that's it for today. And for us cliffhanger, how do you make brown?